Okay, so I want to just show you what I'm working on today. I'm continuing kind of building an anomaly detection capability into stats collection. So if you want to collect stats from Linux, Unix command line prompt, all you got to do is write the command that gathers the stats, and then you pipe that into your stats read function, and it produces this raw output. This is what we're looking at right here. So this is all step one. We want to make just a single command, and we want to collect stats. And then what we want to do is the next step is to have some kind of visual output from the command line, alerting, and that to make that easy to configure. And we want to make that alerting easy to not just set hard thresholds, but to be able to set alerts on the score or other things, and that so you can automatically alert on things just by having generic alerts set up to detect anomalies. And this is not perfect anomaly detection. This isn't scientific at all. There is actually a science behind all this, but you get into, are you looking for general anomalies, or are you looking for credit card fraud? And this is not the credit card fraud type of anomaly detection. This is like what's abnormal right now. So this is our raw data that's being collected, and what we have here, if you look at this data, this is total CPU seconds. It's looking at all the processes and adding up the amount of CPU that they're using, and then it's reporting the delta. So we have a 15-minute period here. We know that because we have the number of elapsed seconds between calls, and we had 24, it went from 9 seconds in the previous 5 minutes to 24 seconds, 23 seconds, and 19 seconds. So obviously something was going on. And as far as a percent of average, we have these three buckets that we can use. We have just an overall average. We have an average for if it's a weekday or weekend, because most systems kind of have weekend, weekday variability, at least business systems. This could be tailored pretty easily in the future to deal with things like Netflix, which you would never use this kind of monitoring probably for Netflix, but where you have kind of like probably a high evening use, high weekend use. It's kind of opposite of a business. I guess maybe what we would do some point is kind of be able to configure that, or put a profile. Are you a business, or are you an entertainment type of thing? Are you an on-hour? What kind of hours do you want to use to collect break your averages into? So you have overall average, weekday, weekend, and then you have weekday, weekend, hour of day. So we're getting a little bit more specific. If at Wednesdays at 2 p.m., if you have a high server load every week, well, we don't want to report an anomaly. We want to know that that's normal. If we were to just look at the overall weekly average, that might be considered anomalous. But if we look at that Wednesdays at 2 o'clock, it's totally normal. So we want to get at least down to that kind of granularity. So this is kind of the raw data we're collecting, and this is what the record looks like. And this could pretty easily be charted and graphed or sent to whatever system you want for that. So let's go look at what we have here. So we have this peak, this 15-minute peak, and we have these averages. It goes to almost 200, and it goes almost 300% of average to 235% of average. Okay, and then it settles down. And so on a chart, that would look like kind of low, and then we'd have this high, and it would come down, and then low. Okay, so what do we want to look at? So let's look at the output. So this is the output that's going to be recorded in the hourly aggregation file, and this is the record for that. So what we have is it shows that 10.33. What is that? That's the okay. That's the average for the. No, that's not the average. Yeah, that's the average for the hour. So total, the average CPU seconds was 10.33, which is 128% of normal on average. Okay, so that really doesn't show us necessarily. We would say, oh, that's not that bad, but we had a 15-minute period that was pretty high, right? And we want to kind of can we see that without visualizing it? Can we monitor that as a number? This system is not anywhere near perfect or complete. It's based on experience. It's based on kind of roughly what you need. So this 0.25 here represents, it's saying that 25% of the time during that hour or during the time period, whatever the time period is, 25% of the time, in this case an hour, the value was above 120%. So for most values, if you're within 20% up or below average, it's fairly normal, right? You really only want to detect things outside of those range or worry about those things outside of those range. Now, if things are running at 110% for a week, we want that to show up. But a lot of times that stuff will just show up on your charts or your graphs. It'll still potentially show up. But right now we're dealing with stuff that's a little bit more outside of that range. It says that 42% of the time it was below 80% of normal. So it was actually a lot below normal for most of the time. The remainder of the time it was in that range, whatever's left over. Now this is our score. So our score is 8.17, and that's our max score. So our maximum score achieved during that hour was 8, and we ended the last metric collected for the hour at 0. So that tells us that there was something that happened. It could have been a single peak, or it could have been a long, well, it probably wasn't a single peak because 25% of the time it was over. So we kind of have the data now that we can say, okay, we can kind of see how high things went. And what that 8 represents, if I go back to the data, it's just adding these up. So when you're 120% over average, it's going to start adding your percentage basically into a value. And then as soon as it falls back to normal range, it drops to 0. So it keeps resetting. So if that number is getting really big within the hour, you've got some problems. Once you get into this hourly aggregation, if you have a series of hours where it's ending with a score, a high score, you have a problem. So I feel like I can probably do pretty good alerting, anomaly detection. Eventually all this is going to be visualized in a program like Dash and all automatic. So I'm feeling pretty good about this. This is something I'll be tweaking over time, but I'm kind of liking this scoring system. I think it's going to give me mostly what I want. And it'll at least give me something to go back and start thinking about, what kinds of things are not going to be caught here and how would we catch those, and maybe I'll tweak it a little bit. So the script that does all this is this awk script, and I need to do something about the index here, get that into a variable. But this is basically the script that does that. It's not, it isn't that complicated, really. It looks complicated because of all the big indexes here, but it's just running through your raw data file and then calculating averages. One thing I like about awk is you can just reference max score here and see if it's less than or equal to current score, and it just kind of, even if you never initialize this value, it just assumes 0. Even if you haven't told it that it's a number, it just assumes 0, so it works. I really like that. I don't know if it assumes 0 or no, if that evaluates it true, but you don't have to worry about initializing this value, which would mean checking to see if the index the array contained this index, and if it doesn't, then you would set it to initialize it to 0. Seems to work without that. So anyway, interesting. Okay, so that's what we're working on, and thanks for watching.